Hello, my name is Carlos Barron, and I am in PAF 503, and we'll be going over Pearson's R in Excel as well as linear regression. I think it's important to establish what Pearson R is first, and we want to go over why it's so important. Pearson R is actually the most common measure of correlation. And so, what is Pearson's R? It's the measure of the strength of the relationship between an independent and dependent variable. And so for this example, we're going to have age and average heart rate as the independent and dependent variable of each other. And it's our way to know if the variables we're actually measuring are related and how much they're influencing one another. So in this case, I'm predicting that age has an influence over average heart rate, which we does, but I'm going to go ahead and use this as an example either way. It measures the strength of the linear relationship between the two variables in general. So things to go over when we're calculating Pearson's R. One, is there a relationship? Two, is it a strong or weak relationship? And three, what direction it goes in. And so the way we identify this is to establish where the coefficient are between the values -1 to 0 to 1. And so when we go ahead and find out what Pearson's R is today, we're going to find out what the R actually is and how close it is to -1, 0, or to 1. And so what does that tell us? Well, Pearson's R. Well, if the R is close to 0 or at 0, there's actually no relationship at all. If the R is at 1, positive 1, there's a strong positive relationship. And if it's -1, there's a strong negative relationship. And that positive and negative actually determines the direction that it's going in. The stronger the relationship, the stronger the association of the two variables. And we're actually going to see how to calculate Pearson's R now. So what I like to do now is I like to go ahead and kind of just put in Pearson's R. I'm going to go ahead and calculate this now. And the way we do that was with equal sign. We type in Pearson. And it gives you one array and two arrays. So the arrays, you can actually highlight all the ages here in that first column. Throw in a comma. Then follow it with another highlight. Go ahead and equal. And we get a Pearson's R of 0.88. Notice that it is positive. Right? So there is a positive relationship there. And it is strong because it is above that 0.5 margin there. It is closer to 1, which allows us to see that it is a strong positive relationship in general. All right, and so we're going to go ahead and see how this plays out with another example. And so I'm going to go to example number 2 for us here. So I have AAC students. I have 10 different students. And the first variable is going to be the number of beers per week that the students consume and how it affects body fat overall altogether. And so I'm going to start this all over. I did get a 0.93 strong positive relationship. Let's go ahead and figure this out together once again. And so what we're going to do today is see if my prediction worked. Put in the equal sign, input Pearson. Again, you see array 1, array 2, and those arrays are going to be highlighting the first column there for number of beers consumed a week. Put a comma there. See how it populates in the system right there. Then go ahead and highlight the number percent of body fat within that second column. Push enter and we get that 0.934%, 0.93, sorry, R, which again indicates a strong positive relationship in general. It is above that 0.5 region, close to 1, and that's how we know it is strong. And so we can tell that the number of beers consumed by students per week does in fact have a influence over the amount of body fat that is there. There's a strong correlation between that, so they are relatable. All right, so because they're both have strong correlations there, we can actually take the linear regression form. And so it's linear regression form, excuse me, let me go ahead and cancel this very quickly. And we're going to figure this out together again. So I'm taking my old data again, that old strong positive correlation of 0.88 for age and average heart rate. And we're going to see what the actual linear regression is. Linear regression in general, so you guys are familiar, it's the most basic and commonly way to create a predictive analysis. So we're going to take the data that we got earlier and see exactly how to predict future correlations in general. And so regression estimates are used to describe data and explain relationships between one dependent variable and one or more independent variables. And so I'm going to go ahead and go to my third sheet, and we're going to calculate this for us today. And so the way you calculate this, you're going to actually highlight all your data for both dependent variables and click on the scatter sheet there and mark it as scatter. And we'll go ahead and move this way. Get rid of this right here. And so when we're doing this, we're going to have to pick one plot on this. Go to add trend line. And so what I want to do is make sure it's a linear trend line in general. And we're going to have you guys show the different options, show the equation on a chart, and display the R squared count. Now, you can tell there's a strong positive correlation because of the way the lines were plotted to begin with. And we'll go ahead and show this in the next example as well. But we did see that everything was moving in sort of the same general direction. And for my original guess, I guessed it was a little more on top here. But obviously Excel does it right every time, and it tells you exactly what to expect. And so what does this tell you? When we calculate this, let's make this a little bit bigger so that way you guys can see. Increase font size. All right. So what this tells us here is where we depend on x, where y depends on x, and it connects to the y-axis in general, where y is a function of x per se. And so if we were to plug in an input of x there, let's say someone's age there, we would calculate that out, multiply by that factor here, add 31, and we would get that factor on together. As you notice here, the y squared is still above 1, close to 1, and so there is a strong positive correlation there in general. And we're going to go ahead and show this in the next example as well, just so we know what we're dealing with. So the next example, we're talking about the number of beers per week and the percentage of body fat. And we're going to see exactly where we can tell to kind of create new predictions from now on. And so we're going to do the same thing. In fact, we're going to go ahead and highlight this. I highly encourage for you to go ahead and pause your video if you haven't done so already, to go ahead and input these values in your own chart just so you know exactly what you're dealing with. But this is what you will be doing. Highlight your data. Go ahead and go to charts, go to scatter, mark that scatter so we can know exactly how the scatter point is. And again, you can always tell by looking at the chart itself that all the chart is moving in the same direction. If it moves from left upward to the right hand side, we do know it's positive. And if we check our R, obviously it indicates that it is also positive, but it's sort of moving in that same criteria where it crosses that y-axis there. And we'll just go ahead and pick a point again. And I'm going to go ahead and add a trend line. But before we do that, I kind of want to guess where the trend line is going to be in general. And you kind of have to just pick a point or a line that's in between most of the data, that it's all inclusive. And I'm going to go ahead and say it's going to go right down that center there, if you can see, just if you eye it a little bit. But let's go ahead and see what Excel tells us today. Of course, it's always right. We add that trend line, make it linear. All right. Go to line here, options, excuse me. And we can go ahead and play with that data point here. Move it backwards, just so we know where it crosses that y-axis in general. And display it on a chart, and a chart value again for R squared. Let's go ahead and grab this information here so we can actually see it for once. Pardon me. Let's just increase the size here, make it red, huge. Perfect. And so we weren't too far off from what I said earlier, but as you can say, the R squared is at 0.872 there. And so when we do calculate this, whatever number of x that we do input to this, we're going to multiply it by that one beer that is, by the consumption of that variable there, add the 0.3755, and you will go ahead and be able to predict what the actual outcome is for number of beers that are consumed by that person in general, to go ahead and predict what the body fat will be from now on using Pearson R and linear regression form. I hope this video was helpful. If you do have any questions, you can go ahead and inbox me right below. Thank you for watching.